Some more problem in single proportion test. Next, first problem, that is problem number 10. This is continuous series, right? From the previous video, I'm taking the number, serial number, right? A coin is tossed 10,000 times and its turn ups the head. Discuss 3195 times. Discuss whether the coin may be regarded as unbiased one. So given number of tossing, right, that is sample size 10,000, and getting a head is a success. So small p is equal to probability of getting a head, that is equal to 1 by 2, right? So q is equal to 1 minus p, that is equal to 1 by 2. So I already told you, whenever you are using dice or this thing coin, you are using Bernoulli, that is binomial. Expected value of success, which is equal to E of x, that is equal to NP. So 10,000 into 1 by 2, 5,000, and given observed 5195, right? Okay, yeah. Turns up at number of success, right? Number of hits 5195 times, right? X is equal to 5195. Define a hypothesis. Null hypothesis H0, that is the coin is unbiased. Alternate hypothesis, coin is biased. Test statistics, Z is equal to x minus np by root n pq. Substituting the value 5195 minus 5000 by root of 10,000 into 1 by 2 into 1 by 2. So that is equal to 195 by 50, that is equal to 3.9. Calculated value of Z is equal to 3.9. Now we know all the probability value. So we are having the standard result. Z is lies between plus 3 and minus 3. Minus 3 and plus 3. So we will take the maximum value, that is Z is equal to 3, right? This is the standard for this type of problems, right? So comparing tabulated and calculated values. Calculated value is greater than tabulated, therefore H0 is rejected, the coin is biased, right? Because rejected means the coin is unbiased, is rejected, so the coin is biased. Next problem. Yeah, biased coin was thrown 400 times and the head resulted 240 times. Find the standard error of the observed proportions of head and deduce that the probability of getting a head in a single throw of a coin lies almost certainly between 0.53 and 0.67. Given number of thrown, right? So n sample size n is equal to 400, x be the number of hits resulted, that is the number of success. So given x is equal to 240 times, right? Out of 400 throw you are having 240 hits, therefore sample proportion p is equal to x by n. So 240 by 400, 0.6, right? So q is equal to 1 minus p, that is 1 minus 0.6, that is equal to 0.4. So standard error, it is equal to formula root of pq by n. So that is equal to root of 0.6, 0.4 by 400, that is equal to 0.0245. Probable limits formula is p less than plus or minus 3 root of pq by n. We are taking z is equal to 3, right? Z alpha is equal to 3, that is why. Normally formula is p plus or minus z alpha into root of pq by n. Substituting the value, taking the minus value, that is 0.6 minus 0.0735, that is the lower limit 0.5265. Then take the upper limit, that is plus 0.6 plus 0.0735, 0.6735. Next problem. Experience has shown that 20% of manufactured product is of the top quality. In one day's production of 400 articles, only 50 are of top quality. Show that either production of the day taken was not a representative sample or the hypothesis of 20% was wrong. So first, one day production of 400 articles, that is the sample we are taking. So we are taking sample size n is equal to 400. X be the number of top quality, right? Top quality. So given number of top quality is 50. Out of 400 you are having 50, right? That is X, that is success, right? Out of 400 you are having 50 are top quality, therefore sample proportion P is equal to X by N, so you will get 0.125. now Q is equal to 1 minus P, that is 1 minus 0.125, that is equal to 0.875. Now we are going to define the hypothesis, null hypothesis. So experience has shown that 20% of manufactured product is of the top quality. That is the main claim, right? That is why we are taking the hypothesis like that. Null hypothesis H naught is P is equal to 20%, that is 0.2. Alternate hypothesis H1 P not equal to 0.2, that is two tail we are using, right? So Q is equal to 1 minus P, that is equal to 1 minus 0.2, 0.8. Test statistics. You can use left tail or right tail also, right? It is more than 20%, you can take, or otherwise it is less than 20%, right? So claim is 20% means manufacturer claim is 20%, means you can take left tail. Less than 20%, you can use that also, right? But here we are using two tail test, right? Z is equal to test statistics, Z is equal to small p minus capital P by root of PQ by N, that is equal to 0.125 minus 0.2 divided by root of 0.2 into 0.8 by 400, you will get minus 3.75. so calculated value, take the modulus value, right? If it is a left tail, keep it as it is, then you can compare the result, because tabulated value are also in the negative, right? In the case left tail, only in the left tail case, right? Calculated value Z is equal to mod Z is equal to 3.75. we know all probability a standard normal variate, right, to be lies between plus or minus 3, so Z is equal to 3, we are taking the maximum value. So conclusion, calculated value is greater than tabulated value, therefore H naught is rejected, therefore 20% of manufactured product is not of the top quality, right? Thanks.